Now we'll take a look at density. Density of a substance is the mass of the substance per unit volume. So density equals mass over volume. This should be a formula that you are familiar with from physical science. A metal object has a mass of 150 kilograms and a volume of 1,000 cubic centimeters. Determine the density of the metal object. So if we use our formula, density equals mass over volume, we are looking for the density, so we're solving for D. The mass is 150 kilograms, and the volume is 1,000 cubic centimeters. So since you're solving for D and D is already isolated, you can go straight to calculating 150 over 1,000. So density is going to be 0.15 kilograms per centimeters cubed. To find the density of the water in the cylinder, again, we are looking for D. The mass is 500 grams, and the volume is 500 centimeters cubed. Again, since we're solving for D, and D is already isolated, we just need to calculate 500 over 500, which is 1 gram per centimeter cubed. And that is the density for water, always. The density of pine is generally about 0.5 grams per centimeter cubed. What is the volume of the piece of pine if its mass is 400 grams? So this time we're not solving for density, they give us density. So I'm going to substitute in the 0.5 for D. The mass is 400, and we are solving for the volume. So I'm going to put V in for volume. This time our variable is not isolated, so we need to get the V by itself. There's multiple ways that you can do this, but we've done a lot of cross multiplication, so I'm just going to kind of stick with that. So that's going to give me 0.5 V equals 400, and then I'm going to divide by the 0.5 to get the V by itself. And 400 divided by 0.5 is 800, and we just need to make sure that we put the correct unit on here. Since it's volume, we can look in the original density and see that the volume was measured in cubic centimeters. It's very common to use cubic centimeters, although it doesn't have to be. For our next example, we've got a rectangular block of copper metal, and we know that it weighs 1,896 grams. We have the dimensions of the block are 8.4 centimeters by 5.4 centimeters by 4.6 centimeters. We're looking for the density. So we are solving for D. We know that the mass is 1,896 grams. The volume they did not give us, but we know it's a rectangular prism, so we will use our formula for a rectangular prism. Length times width times height. So I multiply the three dimensions together. It should give me 212.52, and I'm going to leave it exactly like that. I'm not going to round it to 213 or 212.5. I want to be as exact as possible. And then once I have that, then I will do 1,896 divided by the 212.52. And then here for that one, it would be okay to round. It's going to be approximately 8.9, we'll just round to the tenths, and that would be in grams per centimeter cubed. And it's centimeters cubed because the dimensions of the block were all in centimeters. For our last example, we're looking at a cone that has a radius of 1 and a height of 3. So I'm going to go ahead and draw in that radius of 1 and a height of 3. Using those measurements, we can find the volume. So we'll go ahead and do that for volume of a cone. It is pi radius squared times height all over 3, base times height over 3. So if I do the math there, those 3's are going to cancel each other out. 1 squared is 1, so the volume is just pi. We know that the mass of each dot is 1 gram, and we're looking for the density. So we are looking for D. We're going to have to figure out the mass. We just figured out the volume was pi. So I'm going to count how many dots are in that picture. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 dots, it's going to be 12 grams for the mass. And so I'm just going to do 12 divided by pi. Again, we're going to use pi, not 3.14. We are going to need to round this, but our density is approximately 3.8. And that was in grams, and we were not given a specific unit for the cone, so we're just going to say units cubed.